Okay, this is a rate times time equals distance problem. So I'm going to start by putting that down. Rate times time equals distance. And then I'm going to draw a chart underneath it. And we're talking about Kellen going upstream and downstream. Now, in the past, we've done stuff like R minus C for upstream and R plus C for downstream because we didn't know the rate. But this time we do know the rate. The rate is 12. So this R, we don't need to have a variable for it. It's just going to be 12. Okay? The time, we don't know, but it says that she can go 6 miles upstream, so that's just going to be 6, in the same amount of time that it goes 10 miles downstream. So that's going to be a 10. So here we have this times this is equal to this. We don't know this, but we do know that this has to be a fraction. And in the denominator of the fraction, we have to put 12 minus c, because when we multiply, this is going to cancel and we're going to end up with 6. So the top of the fraction has to be equal to 6. Now when we multiply, those go away and we end up with 6. So here we're going to do another fraction, and in the bottom of the fraction I'm going to put 12 plus c, and in the numerator I'll put 10, so that when I multiply, these cancel and I end up with 10. Now the equation is going to come from the fact that it says it took the same amount of time. Same is equals. So these two boxes are going to be equal to each other. So 6 over 12 minus c is going to be equal to 10 over 12 plus c. And when you have a single fraction is equal to another single fraction, you can cross multiply. When I multiply this way, I get 120 minus 10c is equal to, when I multiply this way, I'm distributing, 6 times 12 is 72 plus 6c. This c is negative, so I'm going to bring this c to the right by adding it, and I'll get 6c plus 10c is 16c, and I'll bring this 72 to the left by subtracting it, and 120 minus 72 is 28 plus 20, that's 48. Finally, we're going to solve for c by dividing each side by 16, and we're going to get c is equal to 48 divided by 16 is 3. So this is in miles per hour. So the current is 3 miles per hour. And that's it. Okay, on his drive from Montpelier, Vermont to Columbia, South Carolina, Dylan Davis averaged 51 miles per hour. If he had been able to average 60 miles per hour, he would have reached the destination 3 hours earlier. What was the driving distance between Montpelier and Columbia? So this is the rate times time equals distance. So let's start there. Rate times time equals distance. And we're talking about a actual trip and an if he did this trip. Okay? Actual. Okay. Now, it says that he actually averaged 51 miles per hour. And if he drove, he would have been driving 60 miles per hour. Now, we don't know how much time he took actually, but we do know that if he went 60 miles per hour, he would have gotten there with 3 hours less time. So when we multiply across, we get 51x and 60 times x minus 3. Now the equation is, this is the same trip, so the distances have to be the same. So those are going to be equal. So I'm going to say 51x must be equal to 60, and I'll just distribute this. So I'll get 60x minus 180. So I'll bring this over to the right by subtracting it, and I'll get 60 minus 51 is 9x, And I'll bring this over to the left side, and we're going to get a positive 180 over there. Then I'm going to divide each side by 9, and we're going to get x is equal to 20. Now, the question is asking, what's the distance? Right now, x represents a time. To find the distance, we need a 51x. And I could put it in here or here, but this is easier. So I'm going to plug it in there. 51x is 51 times 20. Well, 51 times 2 is 102, so times 20 is 1020. So it would be 1020 miles. And that's it. Okay, a plane traveled from San Francisco to some secret place. It averaged 200 miles per hour. On the return trip, it went 300 miles per hour, and the total time traveled was 4 hours. Let's start with the easy part. This is a rate times time equals distance problem. And this plane is going there and back. Okay, now, on the way there, it averaged 200 miles per hour. So let's put that in. On the way back, it went 300 miles per hour. If the total time traveled was 4 hours, now we don't know what this is or what this is, but we know they add up to 4. So choose a variable x for either one of them. It doesn't matter which one. But because we know the total is 4, then this other one's got to be 4 minus x. And these could have been backward. That's okay. Anyway, since rate times time is equal to distance, I'm multiplying these to get this. So this is 200 times 4 minus x, and this is 3x. Because this is a round trip, the distance, if we start here and we go to some point there, and then we turn around and go back, the distance each one went is the same. It's the same trip. So the equation is 200 times 4 minus x must be equal to 3x. Oh, why did I put 3x? 300x. Oops. Okay. All right, now, I'm going to distribute this, and we're going to get 800 minus 200x is equal to 300x. I'll bring this 200 to the right by adding it. 200 plus 300 is 500x. And then I'm going to divide by 500. And I'll bring my answer up here. And I'll have x is equal to 800 divided by 500 is 1.6. Now, 1.6 represents a time that he took to come back. The question is how far. Since these and this is equal, I need to find this, and that's the distance between the two spots. That's the distance back. So 300x is 300 times 1.6, and I'm going to grab a calculator, and I get 480. So they're 480 miles apart. And that's it. Okay, on the first part of the trip to Carmel, traveling on the freeway, Marge averaged 60 miles per hour. On the rest of the trip, which was 10 miles per hour longer than the first part, she averaged 50 miles per hour. Find the total distance. Well, let's start with the easy stuff. This is a rate times time equals distance. So I'm going to just make the chart. I'm going to write the chart out. Then I'm going to just start filling things in as I read them. We have a first part of the trip that they're talking about and a second part of the trip. Okay. On the first part, Marge averaged 60 miles per hour. So that's the rate on the first part. On the rest of the trip, which was 10 miles longer than the first part, so the distance here is 10 miles longer than that, she averaged 50 miles per hour. So on the second part, she went 50 miles per hour. Now, This problem gives you this and this, but it doesn't give you this. But we know that this times this is equal to this. So I need to make a fraction here. On the bottom of the fraction, I'm going to put 60. On the top, I'll put x. Because now when I multiply it, these 60s cancel, and I'm left with x. So if you know one of the factors and you know the product, the other factor is the product divided by the other factor. So anyway, this one I'm going to make a fraction again. I got to get rid of the 50, and I got to put x plus 10 on the top because these cancel, and that's going to be equal to that when I multiply. All right, so now it says, find the total distance if the second part took 30 minutes more than the first part. So this is 30 minutes, which is a half an hour more than this. Because this is bigger, in order to make them the same, I have to add the half an hour to the smaller one. Then I can make them equal, because this is bigger than this. So I'll have x over 60 plus my half an hour, not plus 30, but we're working in hours. This is miles per hour, not miles per minute. So I have to convert this to hours. So if I add a half hour to the smaller one, it's going to be equal to the larger one. That's a little tricky. Now, in order to do this, I have three fractions in my equation. The first thing I'm going to do is figure out my LCD. My LCD is 300x. Oh, not x, just 300. Okay? So I'm going to take this and multiply by 300. I'll take this and multiply by 300. And I'll take this and multiply by 300. And then what's going to happen is I'm going to cancel. 60 goes into this 5 times, and I get 5x. 2 goes into this 150 times, so I have 150. And 50 goes into here 6 times, and then I'm going to distribute that 6 and get 6x plus 60. Now I'll move my 5x to the right by subtracting it. 6x minus 5x is 1x. I'll move my 60 to the left by subtracting it. 150 minus 60 is 90. Now I found x is equal to 90, and I got to make sure I know what that means. That's the distance on the first part. The question asks, what's the total distance? Well, this x is only the distance on the first part. The distance on the second part is x plus 10. 90 plus 10 is 100. So I went 90 on the first part, 100 on the second part, so 190 altogether. So the total trip was 190 miles. And that's it. Number 49 is a work rate problem. It says, Butch and Peggy want to pick up the mess that their grandson Grant has made in his playroom. Butch could do it in 15 minutes working alone. Peggy, working alone, could clean it in 12 minutes. How long will it take them to, if they work together? So what you do on these problems is you make a individual side and you make a together side. All right, so on the individual side, Butch can do it in 15 minutes, so his work rate is 1 over 15. Peggy could do it in 12 minutes, so her work rate is 1 over 12. Together, how long? We don't know, so we'll put 1 over how long is x. Now, our LCD, you could either just go 12 times 15, or if you can see it, it's 60. Okay? So I'm going to multiply each of these fractions by 60. And actually, honestly, if you didn't know that it was 60 and you just said the LCD whatever 12 times 15 is, you'll get the same answer. It's just your work is going to be a little bit bigger than it needs to be. Anyway, 15 goes into 60 4 times, so we have 4 plus 12 goes into 60 5 times, so we have 5 equals, this is, the LCD is 60x because I also have an x in the denominator. So I have to multiply everything by 60x. So I get a 4x and a 5x. Okay. and I'm multiplying by 60x. So now the x's cancel, and this is going to be equal to 60. So now we have 9x is equal to 60, and if I divide each side by 9, I get x is equal to 60 over 9, which is reducible by 3. 3 goes into this 3 times, into this 20 times. So it's 20 over 3. Now that's a weird way to write this, so I'm going to say 6 2/3, and this is done in minutes. So this is minutes. 6 2/3. This is working together. Okay, Jerry and Kuba are laying a hardwood floor. Working alone, Jerry can do it in 20 hours. If they work together, they can complete it in 12 hours. How long will it take Kuba to lay the floor working alone? So again, it's a work rate problem. So I'm going to have the individual stuff on one side and the together stuff on the other side. Okay, Jerry can do the job in 20 hours. So his work rate is 1 over 20. The two of them together can complete it in 12 hours. Well, that's a together thing, so that's going to be 1 over 12 for the work rate there. The question is, how long could Kuba, who's an individual, could he do it on the working alone? So x is Kuba's rate, the time Kuba can complete the job. So here, my LCD is 20 and 12 both go into 60, so 60x again. And again, if you didn't know that, you could just multiply 20 times 12 to get 240. You could have made this a 240x. That works as well. Anyway, I'm going to use 60x because that's the smallest. And I'm multiplying each one of them by that. 20 goes into 60 3 times, so I have 3x here. Here the x's cancel, so I have plus 60. And here 12 goes into 65 times, and you get 5x here. I'll move the 3x to the right by subtracting it. 5x minus 3x is 2x. And I'll divide by 2, and we'll get x is equal to 30. Remember, that's Kuba's time. So how long will it take Kuba to work alone? Kuba would take 30, and the unit is hours working alone. And that's it. Okay, a vat of acid can be filled by an inlet in 10 hours and emptied by an outlet in 20 hours. How long would it take them if they were working together? So again, this is a work rate. So we have our individual stuff on one side and our together stuff on the other side. Now, the vat can be filled by an inlet pipe in 10 hours. That's individual, so that's 1 over 10. And it's positive because it's doing positive work. It's filling it. But it can be emptied by an outlet. That's still an individual. It's emptying. But this time it's going to be negative because it's doing negative work. It's undoing the work that the fill pipe is doing. If they're both open together, how long would it take? So the together is that side, and it's 1 over x. Now, our LCD is 40x. So if I multiply this by 40x, this by 40x, and this by 40x, 10 goes into 40 4 times, so we have 4x here. 20 goes into 40 2 times, so we have a 2x there. And here, oh, you know what? The LCD was actually 20x. I could have made it smaller, but that's okay. I used 40, so I'm just going to stick with it. You'll get the same answer either way. So this is going to be 40. So 4x minus 2x is 2x. And if I divide by 2, I get 20. So x will be 20. So it will take 20 hours if both pipes are open. Now I want to show you what would have happened if I had used 20. So pretend 1 over 10 minus 1 over 20 equals 1 over x. If I realized that the LCD was 20x, then 10 goes into 20 two times, so you have 2x here. Here the 20s cancel, so you have negative x. And here the x's cancel, so you have 20. And 2x minus 1x is x equals 20. You still get the same answer. The math was easier because the numbers were smaller, and that's because I chose the correct LCD at that time. But any common denominator will work. It doesn't have to be the least common denominator.